Good afternoon, Grade 8 learners. This is your School on the Air in Mathematics 8. I am Teacher Nancy B. Pineda of Benigno S. Aquino National High School, your Grade 8 Regio teacher. But before we start, kindly prepare your self-learning module or your book, your pen, and paper to write your solutions and answers as we progress with our discussion. Also, look for a place in your home where you feel comfortable and safe. And most importantly, prepare yourself to watch and listen carefully. We are now on the second quarter week 1 lessons in Mathematics 8. For this week, you will learn how to differentiate linear inequalities in two variables from linear equations in two variables. Illustrates and graphs linear inequalities in two variables. Solves problems involving linear inequalities in two variables. For the first competency, differentiates linear equations from linear inequalities. The difference between linear equations and linear inequalities. Linear equation in two variables is a mathematical sentence that uses the equality symbol or equal sign. It can be written in the form ax plus by equals c, where a, b, and c are real numbers. A and b are not both 0. While the linear inequality in two variables is a mathematical sentence that uses the symbols of inequality. These are less than, greater than or equal to, or less than or equal to. It can be written in the forms ax plus by less than c, ax plus by greater than c, ax plus by is less than or equal to c, or ax plus by is greater than or equal to c, where a, b, and c are real numbers. A and b are not both 0. Here are some examples of linear equations and linear inequalities. For linear equations, we will be using the equal sign for each equation. For number 1, we have 2x equals y minus 7. Number 2, 4x minus 5y equals 20. Number 3, y equals 5x minus 7. 4, x plus y equals 2. Number 5, 2y equals x minus 7. We also have examples for linear inequalities. Again, for linear inequalities, we will be using the symbols less than, greater than or equal to, and less than or equal to. Example 1. 3x minus y is greater than 2. Number 2, x plus y is less than 2. Number 3, x plus 3y is less than or equal to 0. Number 4, 5y minus 3x greater than or equal to negative 3. And number 5, we have 7x is less than or equal to negative 3x minus 5. The difference between the linear equations and linear inequalities is that in linear equations, the symbol we use is equal sign, while in linear inequalities, the symbol that we'll be using are less than, greater than, less than or equal to, and greater than or equal to. Now let's move on to illustrating and graphing linear inequalities in two variables. Before we proceed to the steps in graphing linear inequalities in two variables, let us have first these notes in graphing linear inequalities in two variables. The graph of a linear inequality in two variables is the set of all points in the rectangular coordinate system whose ordered pairs satisfy the inequality. When the line is graphed in the coordinate plane, it separates the plane into two regions called half planes, and the line that separates the plane is called the boundary line. To draw the boundary line, remember this: if the inequality sign is greater than or less than, the line is dashed or broken line. While if the sign is greater than or equal to or less than or equal to, the line will be a solid line. When dealing with just x and y, if the sign is greater than or equal to, the shading either goes up or to the right. If the sign is less than or equal to, the shading either goes down or to the left. The solution in linear inequalities in two variables is an ordered pair that makes the inequality a true statement. Now, here are the steps in graphing linear inequalities in two variables. Step 1. Replace the inequality symbol with an equal sign. Step 2. Find the x-intercept and y-intercept. Step 3. Locate the x-intercept and the y-intercept in the Cartesian plane. Step 4. Connect the points to draw a boundary line. Use a solid line when the inequality symbol uses less than or equal to and greater than or equal to. This means that the points on this line are part of the solution set. And use a broken line or dashed line when the inequality symbol uses less than or greater than. This means that the points on this line are not part of the solution set. Step 5. Test point. Choose a point not on the boundary line and substitute it into the original inequality. If a true statement results, shade the half plane containing the point. If a false statement results, shade the half plane that does not contain the point. For example number 1, graph the solution set of x plus y is less than 3. Step 1. Replace the inequality symbol with an equal sign. So in here, the inequality x plus y is less than 3 becomes x plus y equals 3. Step 2. Find the x-intercept and y-intercept. To find the x-intercept, let y is equal to 0. Copy the equation x plus y is equal to 3. Then substitute 0 in place of y. We have x plus 0 is equal to 3. X is equal to 3. The x-intercept of the inequality x plus y is less than 3 is 3, or the ordered pair for this is 3, 0. To find the y-intercept, let x is equal to 0. We have x plus y is equal to 3. Change x into 0. We have 0 plus y is equal to 3. The result is y is equal to 3, or the ordered pair is 0, 3. In step 3, we can now plot the x and y intercepts of x plus y is less than 3. We have 3, 0, and 0, 3. Step 4, connect the points to draw a boundary line. Reminder, use a solid line when the inequality symbol uses less than or equal to or greater than or equal to. And use a broken line or dashed line when the inequality symbol uses less than and greater than. In this inequality x plus y less than 3, the inequality symbol is less than. Therefore, the line for the boundary line is a broken or dashed line. So, connect the 2.03 and 30 using a dashed line. For step 5, after drawing the boundary line, the plane is divided into two regions. These two regions are called half plane. Once we have graphed the boundary line, we can decide which half plane to shade by using a test point. The test point could be any point that is not on the boundary line itself. We can choose any point for the test point as long as it does not lie on the boundary line. Since the origin does not lie on the boundary line, we will use 0, 0 as our test point. We chose the origin because the coordinates are easy to substitute into the inequality. Substitute the coordinates of the test point into the inequality. We have the original inequality is x plus y is less than 3. Substitute the origin, which is 0, 0. We have 0 plus 0 is less than 3. The result is 0 is less than 3. And 0 is less than 3 is true. Remember that if the resulting statement is true, shade the half plane that includes the test point. On the other hand, if the resulting statement is false, shade the region that does not include the test point. For this, the resulting statement is true, therefore, shade the side containing 0, 0, or the origin. So here is the graph of the inequality x plus y is less than 3. The solution set of x plus y is less than 3 is the shaded portion of this graph. For example number 2, graph the solution set of y plus 2x is greater than or equal to 4. Step 1, replace the inequality symbol with an equal sign. Our original inequality is y plus 2x is greater than or equal to 4 becomes y plus 2x is equal to 4. Step 2, find the x-intercept and y-intercept. To find the x-intercept, let y is equal to 0. Copy the equation y plus 2x equals 4. Then substitute 0 for y. We have 0 plus 2x equals 4. The result is 2x is equal to 4. Then, to get the value of x, divide both sides by 2. We have x is equal to 2. The x-intercept is 2 or 2, 0. And to find the y-intercept, let x equal 0. Copy the equation y plus 2x equals 4. Then substitute the value of x, which is 0, into the equation. We have y plus 2 times 0 equals 4. The result is y plus 0 is equal to 4, or y is equal to 4, or the ordered pair is 0, 4. Next, plot the x and y-intercept in our Cartesian plane, 2, 0, and 0, 4. And then connect the points to draw a boundary line. For this, the inequality symbol is greater than or equal to. Since our inequality symbol is greater than or equal to, connect the 2 points using a solid line. This will be our boundary line. And for step 5, to know the shaded region or shaded portion, or the solution set of y plus 2x is greater than or equal to 4, use a test point. Since the line did not pass through the origin, we can use the origin as our test point. Substitute the ordered pair 0, 0. Into the original inequality, we have y plus 2x is greater than or equal to 4. We have 0 for x and also 0 for y. We have 0 plus 2 times 0 is greater than or equal to 4. The result is 0 is greater than or equal to 4. This statement is false since 0 is not greater than or equal to 4. Again, if the resulting statement is true, shade the region where the test point is located. And if the resulting statement is false, shade the half plane or the region that does not contain 0, 0. So in here, since the resulting statement is false, we will shade the half plane or the region that does not contain 0, 0. So here is the graph of the solution set of y plus 2x is greater than or equal to 4. And for example number 3, graph the solution set of y is greater than or equal to 2 over 5x plus 3. For step 1, replace the inequality symbol with an equal sign. Change the inequality symbol greater than or equal to with an equal sign. The inequality becomes y equals 2 over 5x plus 3. Step 2, determine the slope and y-intercept. In this example, we can use the slope-intercept method to graph this inequality. From our previous lessons in quarter 1, we have graphed linear equations using the slope and the y-intercept. So in here, we just have to determine the slope and the y-intercept of y equals 2 over 5x plus 3. The slope is equal to 2 over 5 and the y-intercept is 3, or the ordered pair for this is 0, 3. Then graph the inequality by using the y-intercept 0, 3, and then locate the second point by using the slope 2 over 5. For step 3, plot the y-intercept 0, 3, and locate the second point by using the slope m is equal to 2 over 5. And then connect the points to draw a boundary line. For this inequality, the inequality symbol is greater than or equal to. Therefore, we will use a solid line to connect the 2 points. And for step 5, use a test point. use the origin 0, 0 as test point, then test it in the original inequality. The inequality is y is greater than or equal to 2 over 5x plus 3. Substitute 0 for x and 0 for y. We have 0 is greater than or equal to 2 over 5 times 0 plus 3. The result is 0 is greater than or equal to 0 plus 3, or 0 is greater than or equal to 3. This statement is false, and if the statement is false, shade the half plane or the region that does not contain 0, 0. So in here, the shaded region is the region opposite the side of the origin. Here are some reminders on using a test point. Note that although all of our examples allowed us to select 0, 0 as our test point, that will not always be true. If the boundary line contains 0, 0, you must select another test point that is not contained on the line as your test point. We can only use the origin as our test point if the line did not pass through the origin. For our third competency, solve problems involving linear inequalities in two variables. Here are some keywords to recall for linear inequalities. We will use less than if less than or fewer than is stated in the word problem. We will use less than or equal to if less than or equal to, no more than, does not exceed, or at most is stated in the word problem. We will use greater than if greater than or more than or exceeds is stated in the word problem. We will use greater than or equal to if greater than or equal to, or at least, or no less than is stated in the word problem. For our example, Miss Angel bought 4 kilograms of oranges and 5 kilograms of apples. She paid not more than 524 pesos. If a kilogram of apple is 40 pesos, then how much is the cost of orange per kilo? To solve this problem, let us follow these simple steps. Step 1. Represent the unknown by using variables. Let x equals the cost of oranges and y be the cost of apples. Step 2. Write a linear inequality. Our keyword for this problem is not more than. Therefore, we will use the inequality symbol less than or equal to. So the linear inequality is 4x plus 5y is less than or equal to 524. Step 3. Solve the linear inequality. The problem is how much is the cost of orange per kilo. Since a kilogram of apple is 40 pesos, let y is equal to 40. It is 4x plus 5y is less than or equal to 524. Substitute the value of the apples, which is 40, or y is equal to 40, into the inequality. We have 4x plus 5 times 40 is less than or equal to 524. We have 4x plus 200 is less than or equal to 524. Then, subtract 200. On both sides of the inequality, we have 4x plus 200 minus 200 less than or equal to 524 minus 200. We have 4x less than or equal to 324. Then divide both sides by 4. The result is x is less than or equal to 81. Therefore, the oranges cost less than or equal to 81 pesos per kilo. That's all for this week's lesson. Tune in again next time for another lesson in linear inequalities in two variables. Thank you, grade 8 students, and God bless us all.